Hello guys, welcome to this new video. This one is a requested question for transformation. Question number 10 of paper May, June 2016, paper 2-2. Okay, so here we have a few shapes, A, B, C, and D. So we have 4 triangles. Let's see what happened to them, okay? So part 1, the perimeter of A is this, where A and B are integers, so find the value of A and B. Okay, so let's find that. So it says it is drawn on a centimeter square grid. What does it mean? It means that every length here is 1 centimeter, 1 centimeter. This is what it means. Now we have to find the perimeter of the triangle A. So we just have to count the side. So this is 1, this is 2, so that will be 2, and this is 1. And what is this length? As you can see, this one is a right angle triangle, so we can find this length by using the Pythagoras theorem. So let's call this one h. So h square is equal to 2 square plus 1 square. H will be root of 5. So the perimeter will be h, which is root of 5, plus 2 plus 1. That will be 3 plus 1 root of 5. So a will be 3 and b will be 5. That is part 1, pretty easy. Now move on to part 2. Triangle A is mapped onto triangle B by a translation T. Write down the column vector of T. So pretty easy. If you count, we can see this point became this point. So how do you move from this point to this point? You count 1, 2, 3, 4, 5, 6, and 1, 2, 3. So when you move to the left, it is negative. So negative 6, and going up is positive 3. So that will be your translation column vector, part B. Now for part C, describe fully the single transformation that maps B onto the triangle C. So let's see what happened here. So we have B and we have triangle C. How can you map this directly onto this one? Now by observation you can look, you have to definitely observe. So this will not be an enlargement because the size did not change, okay? So it cannot be a translation because the direction changed. Now we have a few options. It can be a rotation or it can be a reflection. Now by trial, you will see that if you turn your paper like this, you can see that it is a reflection in this line. This line is the line y equal to x. So let's write this down. It is a reflection in the line y equal to x. So that will be your 2 marks. That is part C. Now let's move on to part D. Describe fully the single transformation that maps B onto triangle D. So where's B? B is right here and triangle D is right here. Because the size has changed, I can say this one is a enlargement. So now we have to find the factor and also the center of enlargement. So the way we do this is we first have to join the corresponding points. So basically, at first this point, it was here, it became this point. So let's join these two. So we join these 2 points, you will have, and then let's join another one. So this point became this point, so we join. Okay, so here you go. As you can see, these 2 lines meet at this point, so this point has to be your center of enlargement, which is -4, 2. Now for enlargement, we need to also find the scale factor. Now here it was 1, 2, it became 1, 2, 3, 4. So the scale factor is 4 from 2. So from 2 it became 4, so 4 is up, 2, that is 2. But now, since the shape, the image is on the other side of the center, the scale factor has to be -2. So let's write this down. The transformation here is what? It is a enlargement with center. As we have seen, it was -4, 2. So write this down. minus 4, 2, and scale factor given to you by minus 2. So you have to write this, this, and this for your 3 marks. Now for part E, write down the matrix that represent the transformation that maps D onto A. Now we have another one which is D onto A. So as you can see again, the shape has changed. Because the shape has changed, it has to be an enlargement in this case, right? Or just the size. Now this point became this point. And then we have this point became this point. So by doing that, you can see the 2 lines meet at a point. We're just trying to see if it is actually the center O. So it is a center O enlargement. Now what is the scale factor? So from this, it was 1, 2, 3, 4. It became 1, 2. So final over initial, that is half, right? So final length was 2. Initial length was 4, so we write final over initial equal to half. Now since the image is on the other side of the center, it has to be minus 2. Okay, so pretty easy. So we have found that the scale factor for this enlargement is equal to minus half. Now one thing you guys must know is that what is the matrix of a enlargement look like? It will always look like this, with k here, 0, and 0, k here, where k is your scale factor. Okay, so since we know scale factor is minus half, so k will be minus half, and so your matrix will look like minus half, 0, 0, minus half. So until here, everything seems to be pretty straightforward. Now let's move on to part F. Now, the transformation V is a reflection in the line y equal to 0. So what is that line? It is your x-axis. Okay, as you can see, at y equal to 0, it is your x-axis. That is the first information, that V, it is a reflection in the x-axis. The next one, W is a rotation 90 degrees clockwise about 0, 0. That is your origin, and the direction will be clockwise in this direction. Okay, now the single transformation X is equivalent, which is equal to the transformation V followed by the transformation W, which means X, it is equal to, first you have to apply V followed by W. So V then followed by W, that will be equal to X. Now part 1, the point GH is mapped onto the point P by the transformation X, which is this one, which is WV. Now find the coordinates of P. So pretty easy. You can first find the matrix of V and the matrix of W to begin, right? So to find these, we can first draw a axis. This is your X and this is your Y. You always begin with those 2 points. You begin with this one first, which is 1, 0, and this one, which is 0, 1. Now, for V, it is a reflection in the x-axis. So you ask yourself, if you were to reflect this point on the x-axis, it will be still in the same spot, right? So the first point will be the same. So 1, 0. Now how about this one? If you were to reflect on the x-axis, it will become this point. So it will become 0, minus 1. So that is your matrix of V. Now how about W? W, it is a rotation 90 degrees clockwise. So first you look at this point. Clockwise rotation, it will become this point, which is 0, minus 1. And then you look at this point. If you rotate 90 degrees clockwise, it will become this point. So that will be your matrix W. Now we have to find the matrix X. So what is X equal to? W times V. So W is 0, minus 1, 1, 0, times V, which is 1, 0. Okay, so let's solve this. So 0 times 0, 0. So that will be 0. And then we have minus 1, and then we have rows by column, that should be minus 1, and then that will be 0. So that is your matrix X. Okay, now to find the image of this point, pretty easy. As you guys know already, you always do matrix times object equal to image. So matrix is X, which is 0 minus 1 minus 1 0 times object, which is this point G and H, that will be supposed to give you minus H and minus G. So your answer will be minus H minus G. Okay, that is only one mark. Now for part 3, describe fully the single transformation X. So how can you describe this? So you want to know what is this matrix, right? So for example, what you can do here, let's take for example, let's say we have a point. Let's use the point. For example, let's use the point. You can choose any point, that is up to you, but we can just test, right? So the point, I will choose 4 4. Right. Now let me find the image of 4 4 under this transformation. So let's see, matrix times object, which is the point 4 4. What is the image? It will become minus 4 minus 4. So let's have a look on our graph to see what happens with this transformation. So we had the point 4 4, and the point 4 4 became minus 4 minus 4. It became right here. So basically, how did you map this to this? Well, if you observe, it is simply a reflection in this line. In your line, y equal to minus x. So single transformation, to make this become this, we reflect this on this line to become this. You can also check by counting. So 1, 2, 3, 4. 1, 2, 3, 4. So yep. So to make this point become this point, we use the matrix of X, which is this, and this matrix X represent a reflection in this line, which is your line y equal to minus x. So that's how we can describe this by using examples, and you can see on your graph to see exactly what happens, and that's how you can find your answer, and you can be sure that it is the right answer. Okay, so let's write this down. It is a reflection in the line y equal to minus x. Okay, so that will be the last question of this part. So again, I hope that was somewhat helpful. As always, thank you for watching. If you guys have any other questions, any other confusions, let me know in the comments. I will try my best to get back to you as soon as possible. And as always, thank you for watching. I will see you soon.